Okay, this will be video for pre-calculus students. This is Exam 1 Review Part 1. What I'll be doing is going over a lot of the graphing problems on this video. Okay, so first thing I want to mention is you will be given a unit circle for this exam, but not for Exam 3 in the final. And you want to make sure that you know the different forms of sine and cosine, formula for amplitude, period, how to do a phase shift, what vertical translations are, and the other thing is the increment. Whenever you're doing the increment, you're always taking the period and dividing that by 4. Okay, so let's start with a pretty simple problem to do here on this. So we're going to look at this -5 sine x. So the only thing this has is a number in front. So if we do the absolute value of -5, that'll give the amplitude, which is going to tell us the max and min are going to raise from 1 to 5 and -1 to -5. The period, we'll do the formula 2 pi over b. B is the number in front of x, so b is equal to 1. So this is 2 pi over 1, so that it will be 2 pi. Okay, increment, take the period, divide it by 4, reduce the fraction, that's going to give you pi over 2. So it's real important that you know how to do these things. Now this problem, you're going to do a table of values. I generally will do that maybe one time on the test, just to make sure you know how to do that. But you really don't have to do a table of values to do any graph. So what I'm going to do to start with on this one is the first row, we're just going to do y equals sine x. And then the second row, we're going to do y equals -5 sine x, where you just have to do a simple arithmetic process. So if you look at the unit circle down here, remember the sine is the y value. So if you go around this unit circle, you're getting these key y values right here. Okay, you don't really have to worry about any other values, you just worry about these values. So what we'll have on this is, to begin with, the sine of 0 is going to be 0, sine of pi over 2 is 1, sine of pi is 0, and then -1 and 0, and so forth. And you can go backwards, you can just kind of work in reverse, 0, -1, 0, 1, 0, like that, and then you've got this filled out completely. Okay. So what I'll go ahead and do now is we'll go ahead and do a graph on here. And I'm only going to do this through one period on here. So we'll go ahead and get this set up. And what I'm going to have here is just make sure that you do your scale your x-axis. Okay, so we're going by 90-degree increments, like that. And then since we have an amplitude of 5, then you want to go up to, all the way up to 5, and down to -5, like that. Okay, then it's just a matter of filling this in. Okay, sine of 0 is 0, sine of pi over 2 is 1, and so forth. So you cycle through these 5 key points, and then that will be the graph of y equals sine x. Okay, so we've got that. And again, it's real helpful if you get this memorized so that you don't have to spend time looking at values on a unit circle. Now, when we get the final thing, all we're really doing is that -5 is it's multiplying all those y values by 5. So anytime you have a number outside, like if you have this a and this d, those things affect y values, and this inside stuff affects x values. So that's real important to understand, is inside the function affects x, outside the function affects y. Okay, so what I do on this is I can just start with this y value and do -5 times 0 to get 0. So that point does not change. Next y value is 1. So -5 times 1 is -5. That kind of reflects and stretches. Then you're back to 0. So -5 times 0 is still that. Now you're at -1. So -5 Okay, so that will stretch and reflect, and then you can circle in the rest. So that's how that graph would look, is kind of like that then. Okay, so that's a very straightforward problem. Okay, next thing, if you get down to problem number 2, what we're beginning to look at is what happens when you have a period change. So it's a little bit more complicated, not much though. Okay, so the thing that we want to start with is look at the amplitude on here. So again, the amplitude is always that number A that's in front of your trig function. So absolute value of 3 is 3. Just make sure that your amplitude is always positive. Your period is 2 pi over b, and b is the number in front of x. So we're going to do 2 pi over 4 pi. Pi's cross out, reduce the fraction, you get 1/2. So notice on here that I'm asking you to graph this from 0 to 1/2. The intention was to have you graph this over one period, which is typically what I'm going to do in the exam situation. Okay, the increment, you just take 1/2 and you divide it by 4. Now, sometimes students want to do like that, and it's okay to do like that, but remember this just means 1/2 divided by 4, which means you're just doing 1/2 times 1/4. So you're just taking a fourth of the period, really. So that will give 1/8. Okay, so we have this. Okay, and then we're ready to get everything put together. So basically on this problem, what we're going to do is, I'm going to go ahead and just draw an x and y axis. And when we do this increment, that really takes care of that 4 pi part. So we're going to count this out, going from 0, and then we're just going to keep going up by 1/8. So I'll go 1/8, 2/8, 3/8, 4/8, and then I'll reduce each fraction. So I'm going to use 1/8. The next one is 2/8, but 2/8 can be reduced to 1/4. Then I use 3/8. Then 4/8 can reduce to 1/2. Okay, now since your amplitude's 3, that means that the maximum of 1 is going to stretch up to 3. So I'm going to go like this, and I'll go down to -3 like that. Now when I say scale the x and y axis, that's what I'm talking about. You need to tell me what your scale is. If you don't put these numbers, that I've got on my scale, then your graph's wrong. Your graph's actually meaningless if you don't do that. Okay, now let me show you kind of how we do the next part. And I'm going to just refer to the unit circle up here as I do this, because we have a cosine, but it's good to get this memorized. So if we're doing a cosine, you're looking at the x value now. Okay, so I'm just going to highlight those x values, 1, 0, -1, 0. It's going to do that over and over again in a cycle. So now what happens is, at 0 radians, we know the cosine's 1, so I'm going to put a dot there. Now at 1/8, you got to understand that the 1/8 is going to have the same value as pi over 2 would have, because we did a period change. So what's happened is this scale has changed where those key points are. Okay, your angles are no longer going to be 0 pi over 2 pi and 3 pi over 2. So now we go to 0, then we go to -1, and we cycle through those points. Okay, so you don't have to even use the unit circle to do that if you have that memorized. So what this is going to give is, this is going to give the graph of y equals cosine of 4 pi x. When you do the period and increment, and if you have a phase shift, that's going to just change your values on your x-axis. And then what's outside is going to affect y values. So now what I do is I just take that 3, multiply it by each y. This y value is 1, so 3 times 1 is 3. That graph will go there. 3 times 0, the next y value is not going to change. And then we got 3 times -1, which is -3. Okay, so that stretches down there. Then you can just kind of cycle through the points, and then you've got your graph put together like that. Okay, so it's real simple. If you take this kind of strategy, graphing of trig functions can be done pretty quickly. The other thing I want to mention on this is checking, and I like to kind of, as I'm going through these problems, just kind of randomly pick one of these numbers. It doesn't matter that much. I'm going to just say, okay, let's pick 1/4. And what I'm going to do is I'm going to plug that into the original function. So I'm going to do 3 cosine of 4 pi times 1/4. Okay, that'll cross that out. That's going to give us 3 cosine of pi. And then if you look at pi, the cosine of pi, see, is -1. So 3 times -1 is -3. And notice that that matches that y value right there. Okay, so if you just check one point, then that doesn't prove that all of them are right, but it gives you a good sense that you're on the right track. You can check as many points as you want, but usually if you check one point and you've cycled through the points correctly, then you're going to be okay. Okay, so let me move to the next page here. And what we're going to look at here is another one. This problem's pretty similar to the one I just did. It's got just a couple other different features on it. So we'll go about doing this one pretty much the same way. Okay, so the amplitude, we'll start with that. Amplitude is absolute value of -2. That's 2. Remember, amplitude's a positive number always because it's a distance. Period, you do 2 pi over b. In this case, b is equal to 1/3. So I'm going to take 2 pi divided by 1/3. So that will be 2 pi times 3 over 1. So that'll give 6 pi. Okay. So we got that. And then the increment, we're going to do this. We're going to take the period, 6 pi, and then we're going to divide that by 4. Reduce that fraction, that's going to be 3 pi over 2 is going to be what your increment of your x-axis is then. Okay, now we're pretty much ready to roll on this now. So we're going to graph from 0 to 6 pi. And sometimes on an exam, I'll either give you an interval to graph on, or I will just say graph over 1 period. Okay, so we're going to go ahead and count out this increment. So we got 0, 3 pi over 2. Now you're really counting by the numerator, so it's going up by 3. So you'd have 6 pi over 2, 9 pi over 2, and then 12 pi over 2. Okay, so we've got the increment. We'll have 0. Then our first place will be 3 pi over 2. 6 pi over 2 reduces to 3 pi. Then we got 9 pi over 2. And then finally we got 6 pi. And notice on this, when I counted to 5, 1, 2, 3, 4, 5, I made it to the end of that period. Okay, so that's going to take care of where these key points lie. And then we're going to have the -2 for an amplitude. The amplitude's 2, so that's going to stretch the max up to 2 and the minimum down to -2 like that. Okay, now we're ready to go with this. Now you don't even have to look at the unit circle, but again, the cosine is the x value. So we're going to cycle through these points in this order. So we're going to start here and then cycle through to get these 5 key points on our 1 period. So that'll go like that. And then the rest of this is multiplying the y value by -2. So take this y value of 1, -2 times 1 takes you to -2. So this point moves down there. Multiplied by 0, if you do -2 times 0, that's still 0. So that point remains unchanged. And then -1, -2 times -1 is 2. So that point moves up there. So it's a stretch and it's a reflection. And then the rest of these things can be done like that. So now you got your graph. Okay. Now if I want to do a check, I highly recommend you do this. Pick a point, doesn't matter. I'm going to pick 3 pi. I say this only takes a matter of seconds to do this. So you're going to do -2 cosine 1/3 times 3 pi. That'll cross that out, leaving you -2 cosine pi. Cosine pi is -1. So you're going to end up getting 2. See, that doesn't take hardly any time to do that, and it gives you tons of confidence in yourself. You know, I can see you just pumping your fist there. Okay, I got that. That's cool. All right, so they've got that. Now when we get to the next problem, we're going to be looking more at a phase shift now. Okay, so let me kind of get this set up. Let me move this unit circle somewhere over kind of to the side here. Okay, although you don't really need the unit circle if you've got everything memorized on here pretty good, how the graphs go. Okay, so with this one, I think I had a mistake on this problem. So this was intended not to be pi over 3, but it was intended to be pi. Okay, so I'm going to go ahead and work with this down here. So I've got y equals -3 cosine of 3x minus pi, like that. Okay, so we're going to put this in a factored form. Now, first of all, if it's not in a factored form, if you're not in a factored form, your phase shift can be done by doing this pi over 3. You can divide those. That's if you're not in a factored form. So that phase shift is going to be pi over 3 to the right. You can get that right away without factoring. I do like students to know how to factor this, okay? So I'm going to go ahead and just show you how you would do this. So we'll have -3 cosine. Now you always factor out the number in front of x. So you're going to write that like this. Okay, and then you'll have like this. So 3 times x is 3x. And then if you're struggling to figure out what goes here, again, all you do is you just do this number divided by that number. So you're going to get a minus pi over 3 like that. Okay, it's always this number pi divided by the number in front of x. Okay, now if we go through and get the rest of this put together, the amplitude on this is going to be absolute value of -3. So that's 3. That'll tell us something about our max and min. The period, we're going to do the formula 2 pi over b. And again, b is 3. So we have 2 pi over 3. So that's our period. And then finally, the increment will tell you how to get your x-axis put together. So we're going to do 2 pi over 3 divided by 4, but that's the same as multiplying by a fourth. Multiply the fraction straight across. You're going to get 2 pi over 12, and that reduces to pi over 6. Okay, so we've got all of the key things we need. We've got our amplitude, period, increment, and then now we have the phase shift. Okay, so we're all set, and now what we're ready to do is get our graph put together. So I didn't really even need to use my unit circle. You get the graphs memorized, and you can use that as you need to. So what I'm going to do on this is I'm going to have you graph from like, I'm going to say negative pi over 3 to 2 pi over 3 like that. Okay, so I'm going to go ahead and get a graph kind of put together here. And again, I'm going to count out this increment. So this increment is pi over 6. So I'm going to just count this out over here. Again, I am counting the numerator out and then reducing fractions. So see, I've just counted to 5. 1, 2, 3, 4, 5. 4 pi over 6 reduces to 2 pi over 3. So that's the period. Okay, so, and you'll know that increment's right. I mean, if you count to 5, the fifth one should be what the period is. Okay, so I'm going to go ahead and put pi over 6 here. Then pi over 3, because I'm reducing a fraction. 3 pi over 6 is really pi over 2. and then we get 2 pi over 3 like this. Okay, so we got that. I'm also going to back up and do negative pi over 6, and then I'm going to do negative pi over 3 like that. Okay, so now if you look at the numbers in front, those numbers right there are going to kind of tell you how the y values are being affected. So if you take the high point, the maximum of 1, multiply it by negative 3 and add 2, that'll give you negative 1. If you take negative 3 times the low point, negative 1, and work that out, that'll give you 5. So that's going to tell you that your graph needs to go up to 5 and down to negative 1. Okay, you don't have to go all the way down to negative 5 if you don't want to, but we've got everything. We've got our framework built. We got our scale beautifully. Okay, so now if you have a phase shift, this is if you have a phase shift, the way you want to go about doing your graphing is I usually like to just get students to do this in 2 stages. So what you want to do is you want to start at that phase shift. Okay, so this is a phase shift, pi over 3 to the right. Now, if you look at the unit circle again on here, what you'll find is, again, the cosine always starts at 1. It has a y value of 1. So instead of putting the 1 here, we're going to phase shift over to pi over 3, then we're going to put it there. Okay? Then we start cycling through these points. Okay? That's going to go to 0. That'll go to negative 1. And then just cycle backwards through these points like that. And then that will give you the graph of the inner part of the problem. So what I just did is I just graphed y equals cosine of 3 times x minus pi over 3. You kind of work inside out on these problems. That's the inside part right there. Now the rest of the problem is actually very simple. I'm going to start over here, and that y value is 1, so I'm going to do negative 3 times 1 plus 2. Just taking into effect the negative 3 and then the vertical translation. So that'll be negative 1. So that point moves there. Now go with 0. So negative 3 times 0 plus 2 moves that point up to 2. And then take the next y value, negative 1. Work this out. Negative 3 times negative 1 plus 2 will give 5. And that gives you the key points that you need. And then the rest of these things are just going to cycle predictably through these points. So you're going to have that point. This point right here is going to move here. And so forth. Okay, so now you've got a graph of that trig function like that. Okay, so that's how you do that. Right? And if you learn how to use this strategy and practice this strategy, you can get your graphs done really quickly. Okay, but just make sure you start at the phase shift when you have one. I'm going to do one more thing on this problem. I'm going to do a check one more time. I don't care which point you pick. I'm going to pick 0, I guess. Okay, so I'm going to say x equals 0. Go back to the original problem if you want to. That's what I'm going to do. Is just go y equals negative 3 cosine 3x minus pi plus 2. And I'm going to replace x with 0. So I'll get negative 3 cosine 3 times 0 minus pi plus 2. That will give negative 3 cosine negative pi plus 2. Now, if you look at your unit circle on that, negative pi is clockwise, 180 degrees, so that's negative 1. So you have negative 3 times negative 1 plus 2. 3 plus 2 is 5. And look at that. That matches that point. How about that? Okay. This stuff is just so fun. I could just do this all day long. Never get tired of it. All right. So that's how you kind of handle your sine, cosine graphs like that. Now, the next thing I want to focus on here a little bit is how you do the other trig functions. Okay, so let me kind of get my unit circle over here, kind of get this put in the right place here. And then we'll focus on the cosine and the secant here. Okay, so if you're dealing with a cosecant, you want to graph on this problem. Ultimately, what you want to do is you want to graph this. You want to totally focus on graphing y equals 2 sine 1/3 x. So the nice thing about doing a cosecant and a secant is you just have to be able to graph the sine and cosine. Okay, when you do the next problem, number 6, you want to graph y equals 3 cosine x plus pi over 2. Okay, so got to be a little bit careful on this. And one of the things that on this is the only two trig functions that have amplitude. You have an amplitude, you have a sine and a cosine have an amplitude. There's no amplitude on anything else. So there's no amplitude on a secant, a cosecant, a tangent, and cotangent, because what an amplitude is it's half the distance between the max and min. Okay, so you have that. So the answer here is there's no amplitude. The period is still the same formula. It's 2 pi over b. Okay, in this problem, b is 1/3. So that's your b value. So we're going to have 2 pi divided by 1/3. Just make sure the answer is positive. So 2 pi times 3 is going to give you 6 pi. That's your period. Okay. Increment, same thing, 6 pi divided by 4. The increment is always the same on every trig function. So that's going to be 3 pi over 2 like that. Okay? Now, what we're going to do, well, don't worry about the equation of the vertical asymptote yet. We'll kind of get to that after we do the graph, because you have to identify where a vertical asymptote is. So at the beginning, so we're not really doing anything much different than we were doing earlier in the video. So we're going to go ahead and set up our increment here. And when we count out the 3 pi over 2, we have 0, 3 pi over 2, 6 pi over 2, 9 pi over 2, and finally we make it to 12 pi over 2. And again, reduce the fractions. So notice 1, 2, 3, 4, 5 gets you to that period 6 pi. Okay, so get your x-axis set up. We'll have 3 pi over 2, 3 pi, 9 pi over 2, and then we'll have 6 pi like this. Okay, now a cosecant, the graph is going to go above and below the max, so you want to go above 2 and negative 2. So I'm going to just go 1, 2, 3, 4, 5, and then down to negative 5 like that. Okay, now we're ready to put this thing together. So here's how we do this. Everything has been put together, so we're going to go ahead on this, and I'm going to lightly put in these points. So what I'm really going to do is I'm going to graph y equals sine of 1/3 x, but I'm not going to really graph it. I'm just going to put the dots there. So we have there, and I'm just cycling through these points on a sine. Now, if I throw in the 2, you can now do this in your head. All you're doing is 2 times 0, so that point is still at 0. You do 2 times 1, that point moves to 2, and I'll just kind of erase that. This point is 0. This point will stretch down to negative 2, and this point will stay at 0. Okay, so you can do that in your head. You don't have to do like extra graphs. That's the key thing right there. So this that I just drew, that is the graph of y equals 2 sine of 1/3 x. So it goes like that. Okay, now the asymptotes occur at the midpoints. Okay, not x-intercepts. Don't think of it that way. It's at the midpoints. Okay, the midpoint just meaning halfway between the max and min. You have a max of 2, a min of -2, 0 is the midpoint. So what I'm going to do is I'm going to draw vertical asymptotes through these midpoints, like this. Okay, then I just sketch in the shape. So the shape goes like this then. So the shape of your final graph will look like this. You just kind of put the U shape on top. My teacher taught me in 1980, whatever, too, that you just think of this as a camel, and that's on top of the camel's hump. This is the camel's fat belly, so you make it go up from the camel's fat belly. That's how I was taught way back when. Okay, so that's your graph right there. So notice that what we did is we graphed the sign, and then the rest of it's sketching. It's knowing where the asymptotes are. So if you want to find an equation of an asymptote, there's two ways to do it. You have vertical asymptotes at x equals 0, 3 pi, 6 pi, 9 pi, and then there's a pattern. Okay, now those things are going by multiples of 3. So it can be a little tricky to write this just doing the pattern on that. So it's really what it is x equals k pi, where k is a multiple of 3. It's an integer multiple of 3. And a person could write it that way. You could say x equals k pi, where k is an integer multiple of 3, and that would be a perfectly valid way of doing that. You also have a formula. The formula is just x equals, pick a vertical asymptote. I don't care which vertical asymptote you pick, just pick it. And then it would be plus half the period times k, again where k is an integer. Okay, so I'm going to pick 0 as an asymptote. So I have x equals 0 plus 1/2 the period. The period is 6 pi times k. So I get x equals 3 pi k, where k is an integer. Okay, so I'll just write this as x equals 3 pi k, k is an integer. So notice on this it's real simple. If k is 0, 3 pi times 0 is 0. If k is 1, 3 pi times 1 is 3 pi. If k is 2, 3 pi times 2 is 6 pi. So that's how you would get that put together like that. Okay, all right. So that's how you would handle that. Next thing that I want to look into here is how to do a secant graph. So I'm going to go ahead and do the secant graph next here. Okay, so let's see. Let's go ahead. When you're doing a secant, what you're focusing on is you're focusing on doing a cosine. Okay, so I'm going to erase some of the things that I did there. Okay, and I'll zoom on this a little bit so you can see. Okay, so now with this one, what our focus is going to be on this one is graphing y equals 3 cosine x plus pi over 2. Okay, so here's your amplitude. So the absolute value of A, 3 is your amplitude. That'll tell you that the max is going to move to 3 and the min's going to move to -3. The period is 2 pi over B. B is the number in front of x, so that'll be 2 pi over 1. So that's just 2 pi. The increment, you take the period divided by 4. That'll give you pi over 2. Okay, so we've got that set up, and we also do have a phase shift on this. So our phase shift is right there. So I'm going to write that we have a phase shift of negative pi over 2. So we're phase shifting to the left because that's a plus sign. So you write the phase shift as negative pi over 2 because it phase shifts to the left. And what I'm going to do on this is when I draw out this increment And with this thing, I'm saying graph from negative 2 pi over 2 pi to 2 pi. So I'm going to go ahead, get this put together, pi over 2, pi, 3 pi over 2, and out to 2 pi, like that. Okay, and then move over here. Okay, what I'm going to have here is I'm going to have negative pi over 2, negative pi, negative 3 pi over 2, and then negative 2 pi like that. Now I'm going to go past 3 because you're going to have, your graph is going to be the U-shapes going infinitely up and infinitely down. So I'm just going to kind of get my scale like that, and that's good enough. Now, your goal on this is to do this first graph really efficiently, and what you want to do is start at the phase shift. The phase shift is negative pi over 2, so you're going to start here. Okay, remember, a cosine starts high at 1. However, we're multiplying that by 3, so that first point is going to go there. Then the cosine goes to 0. If you multiply 0 by 3, that's still 0. Then it moves to negative 1. Negative 1 times 3 is negative 3, so this is how your cosine wave is going. Okay, so you can kind of see what's going on. Okay, it's phase shifting the whole cosine pi over 2 to the left. Now you can just cycle through these key points, and then you're getting your cosine graph put together like this. Okay, now I did that in my head, do what you need to do. But again, really what I'm doing is I'm taking those key points, I'm taking 3 times 1, 3 times 0, 3 times negative 1. That's how the 3 is affecting those points. Now identify the midpoints. So here's the midpoints. This is where your vertical asymptotes lie. So we'll go ahead and just draw vertical asymptotes through the midpoints. And then we're ready to just sketch in the shape, and then we'll get our equations of our vertical asymptotes. Okay? All right, and then just sketch in the U-shapes. The main thing on the U-shapes is just make sure that they get close to the asymptote, but they don't touch that asymptote. Or they don't kiss the asymptote. That's the way I like to look at it. Okay, like I told you all in class one time, I want to make a t-shirt that says, "Kiss my asymptote." I think I'll sell it on the internet and I'll be a millionaire, and then I could retire. And I wouldn't have to make these videos anymore. I'm teasing about that. I like making these videos, though. Okay, so the thing on here is, if you look at your asymptotes, if you write them out, your asymptotes are at 0, pi, 2 pi, so it's just that integer pi. So this one is easy enough that you can just write your answer. You could say x equals k pi, where k is an integer. Okay, that's, if you can see the pattern, then that's good. Now, sometimes it's hard for students to see the pattern, so you could also use this formula, x equals a vertical asymptote plus half the period times k, where k is an integer. So the first asymptote's 0. I like to just, and I don't care which asymptote you use. So x equals 0 plus 1/2 times the period, which is 2 pi. And so you would end up getting x equals 0 plus pi. So you could also write this as, and that would have to be times k. So you would actually just get the same thing. You would just get x equals k pi, where k is an integer. So you can use that formula if you want to. On a secant and cosecant, x equals, pick a vertical asymptote, plus half the period times k. Okay, and that's how that gets put together then. Okay, so I want to, on this video, I'm going to do this video in 2 parts. So with this one, what I want to do is I want to go ahead and finish these graphs up, and then I'll post the video based on this. Let me get my unit circle where I need to have it. Okay, because I'll need to maybe look at the unit circle as I'm doing this problem with a tangent and a cotangent. Okay, so what I'm going to do on this is everything's a little bit different on a tangent. So the amplitude on a tangent and cotangent, there is none. Remember, there's only an amplitude on a sine and a cosine. So there's no amplitude on either of these things. And the period's different too. The period is pi over b. It's different for a tangent and cotangent. So when I do the period here, b is going to be 2, so I just do pi divided by 2. So pi over 2 will be the period on this graph. Okay, the increment is still the same. You're just taking the period, dividing it by 4, but dividing by 4 is the same thing as multiplying by a fourth. So that increment is going to be pi over 8. Okay, vertical asymptote, we're not going to worry about that yet. But one of the things that I like to do on a tangent, this is what I like to kind of show, is look at the unit circle, and you have to understand that the tangent of theta, by definition, is y over x. So you're looking at where x equals 0 to tell where the asymptotes are. So x equals 0 at pi over 2, x equals 0 at 3 pi over 2, and then also remember that's negative pi over 2. So what you do is you set what we call the argument equal to where a vertical asymptote, where the tangent's undefined on the unit circle. So I like to just use pi over 2. So what I'm going to do is the argument is 2x. So I set that equal to pi over 2. Now, I'm going to go ahead also and set that equal to x equals negative pi over 2. Okay, so if I do that, that will give me where 2 of my asymptotes are. If you chose to, you could also set 2x equal to 3 pi over 2, and that would give you where another asymptote is. But it's not necessary. So what I'm going to do is multiply both sides by a half. That's going to give me x equals pi over 4. That's where one of your vertical asymptotes is. Same thing over here. Multiply by a half. You're going to end up getting x equals negative pi over 4. And if you want to do the next one, you could do the same thing. Multiply by a fourth to solve the equation. Not by a fourth, by a half. And if you did that, you would have x equals 3 pi over 8. So the key when you're doing a tangent is to get asymptotes. Okay, you can get 2 of them at a minimum, but you have to know on a tangent, you're setting them equal to the places on the unit circle where you're undefined. So now when I put this together, the increment is going to be pi over 8. So I'm just going to count this out. 0 pi over 8, 2 pi over 8, 3 pi over 8, and 4 pi over 8. So notice on this that there's an asymptote at these 2 locations right here. Okay, at 3 pi over 8 there was an asymptote, and so forth. Okay, this one is pi over 4 like that. Okay, so what I'm going to do on here is I'm going to go ahead and get this set up. So the increment is pi over 8, so I'm going to have pi over 8, then 2 pi over 8 reduces to pi over 4. Okay, then I've got 3 pi over 8. Then I got 4 pi over 8, which is pi over 2 like that. Okay, then I can do the negative ones. I have negative pi over 8, negative pi over 4, negative 3 pi over 8, and then negative pi over 2 like that. Okay, So what we had is we had a vertical asymptote at 3 pi over 8, or no, at pi over 4. So I'm going to put a vertical asymptote through there. I had another vertical asymptote at, let's see, negative pi over 4. And over here, I think I did something not right. Yeah, I saw what I did. I kind of did this wrong down here. Okay, so what happens on this, I was kind of getting in a hurry here. So I have 2x equals 3 pi over 2. And then if I multiply both sides by a fourth, that'll give, by 1/2. What's wrong with me? I get x equals 3 pi over 4. So you would have another asymptote at 3 pi over 4. And really what happens, if you count to 5, you'll just have asymptotes. 1, 2, 3, 4, 5. If I continued, I'd go 1, 2, 3, 4, 5, and I'd get other asymptotes. So I've got that. Now, what I need to do from here is just try to remember what happens on a tangent. So what happens on a tangent graph is it looks like this. And it's good to just get this memorized. So if I was graphing y equals tangent of 2x, not doing the 3 yet, okay, then it would go like this. You just have to remember in the middle of the vertical asymptotes, you're going to have a y value of 0. To the right of that, you'll have a y value of 1. To the left of that, you'll have -1. And the way I'm getting this is like this. Okay, I'm going around this unit circle, and I'm doing y over x. 0 over 1 is 0. Over here, root 2 over 2 divided by itself is 1. Okay, if I go this way and go here, then this is going to give the tangent of negative pi over 4 is going to be -1. That's where I'm getting those points. So what's going to happen is I'm going to adjust these y values by multiplying them by 3. And then I'm just going to kind of move to the left on here to repeat this period. Okay? Now, what I'm going to do is I'm just going to do this in my head. I'm going to start, let's start here. If I do 3 times 0, that is still 3 times, that's still 0. If I do 3 times 1, that's going to move that up to 3, so that part of the graph is going to look like that. If I do 3 times -1, that'll move like that. So that's how that part of the graph will go. And then the rest of this you could just repeat. So that part of the graph goes like this. This part of the graph goes like that. Okay, so that's how that goes. You want to remember what the basic tangent wave does. In between the asymptotes, you're always going to have this shape that goes like that. Okay, so that's how that goes. Now, if we want to get the equation of the vertical asymptote, then we can either use a formula, or you can just figure out the pattern on your own if you want to. So the formula goes like this for the vertical asymptote. It's just x equals, pick a vertical asymptote, then it's going to be plus the period k, where k is an integer. Okay, so what happens on this problem is we have an asymptote. I don't care which one you pick. I'm going to pick pi over 4. The period is pi over 2 times k. Okay, so we're just going to write this answer as x equals pi over 4 plus pi over 2k, where k is an integer. So that's how that problem gets put together. Okay? All right. All of these problems, by the way, could be checked too. I mean, like if you plugged in 0, if you just did this, you know, as a quick check, and it doesn't matter what you pick for a check. If you do 0, you would end up doing 3 tangent of 2 times 0. That would be 3 tangent of 0. And the tangent of 0 is y over x. So it's equal to 0. So 3 times 0 is 0. That's what that y value is, see. So that's how you put that together. Okay, so let me finish with this video with the cotangent graph and get this one put together then. Okay, so again, what I'm going to do on this is, again, there is no amplitude. The period we do pi over b. B is going to be 1. So pi over 1 is going to be pi. The increment is take the period divided by 4. So we have that information. Okay, now what we have to do is we are going to have a phase shift, but I'm not going to really worry about that phase shift. What we're going to do is on a cotangent, you set the argument. And what I mean by the argument, again, is this part right here. That's the part that you're taking the cotangent of. So what we do on this is we look at the unit circle, or you could certainly memorize this. And the idea is you have to remember that a cotangent of theta is equal to x over y. So you're going to find that if you're at 0, you're going to find the cotangent of 0 radians is 1 over 0, so it's undefined. So you're going to set the argument equal to 0. The other place, if you do the cotangent of pi, that would be x over y, so that would be undefined. So you can set it equal to pi, and then you could set it equal to 2 pi, negative pi, and so forth. So what I'm going to do is take the argument, x plus pi over 4, and I'm going to set that equal to 0. And that's going to give me an asymptote. So that's real easy to solve. One of your vertical asymptotes is at x equals negative pi over 4. Now, I'm going to show you on this problem that you don't have to set the argument equal to anything else. I mean, you could. You could do x plus pi over 4 set equal to pi if you wanted to. But it's really unnecessary. So what I'm going to do is let's do the increment. So 0, 1 pi over 4, 2 pi over 4, 3 pi over 4, and eventually we get to 4 pi over 4, which is equal to pi. Okay? So now when I put this together and get this put together, what I'm going to have here is I'll get my graph set up. So I'm going to go pi over 4, pi over 2, 3 pi over 4, and then up to pi, negative pi over 4, negative pi over 2, negative 3 pi over 4, and then to negative pi like that. Now it looks like I have a 2 in front, so I'm just going to make this go up to 2 and down to negative 2 like that. Now let me show you what you can do. And it's real simple, it really is. You have an asymptote here. So just draw your asymptote. Now count to 5. 1, 2, 3, 4, 5. That's where your next asymptote is. Okay, if you count to 5 this way, 1, 2, 3, 4, 5, you would have one other asymptote over there, but that's beyond the scope of our graph, so we don't care about that. Now what you have to remember on a cotangent is halfway in the middle of the asymptote, you have a y value of 0. To the left of that, you have a y value of 1. And to the right of that, it's negative 1. Now what's happening on this problem is you're multiplying by 2. So you're taking 2 times 1. That point gets moved there now. You're going to take 2 times 0, which is still 0. And then take 2 times negative 1. That's going to move down there. Then you can sketch in that shape. That's how the cotangent goes. Then you can just kind of work backwards through the cycle. One step past an asymptote, you'll be there. So that part of the graph will go like that. And then you can just kind of repeat the cycle. That goes like this. Okay, so that's how that graph is going to look. All right, so tangent and cotangent, a little bit different to do. Okay, now we have the same formula, x equals a vertical asymptote, plus the period, k, where k is an integer. You can use the formula if you want to. So I'm just going to use this asymptote negative pi over 4 plus the period, which is pi, times k. K is an integer, and then that gives you the answer to the problem. Okay, so this video I'll post, and it will have just review over the pieces of this. Okay, I did these problems pretty fast on here. This is intended to be a review, but go through the parts that you need to go through and practice working these problems out. Okay, hope this helps you out.